Hi everyone. Today we are going to explore an inspiring and intellectually rich essay written by Neil deGrasse Tyson, a world renowned astrophysicist. The essay was published in Natural History magazine in November 2000. It is titled On Earth as in the Heavens, and in it, Tyson makes a powerful argument about how the same physical laws that govern our world also govern the entire cosmos. We will explore how science becomes the universal language that binds us with the stars and even potential alien civilizations. So, without wasting any time, let's move to the introduction of the chapter. Tyson begins by explaining the philosophical transformation in science. Historically, people believed Earth was governed by different principles than the heavens. But scientific discovery, especially from Newton onwards, has unified these domains. So, Tyson emphasizes the universality of physical laws, that the rules we uncover in our labs apply across the universe. There is no differentiation between Earth and the sky. So, all the physical laws are universally applied. This forms the core theme of the essay. Nature doesn't change its rules depending on the location or time. That's both comforting and powerful. It means we can understand distant stars using Earth based science. Let's look how this transformation began. So, Tyson references Isaac Newton, whose law of universal gravitation showed that the force pulling applies to the ground is the same one keeping the moon in the orbit. He is saying that the gravitational force that is pulling an apple to the ground is the same force which is keeping the moon and the earth in the orbit. The moon is revolving around the earth, and the earth is revolving around the sun, and both are same, and physical laws are the same. So this was revolutionary. This idea was revolutionary because before this, people assumed heavenly motion was mystical or divine, like the moon is orbiting the earth or the earth is orbiting the sun, is something which is mystical or it is divine. But Newton broke that wall. He was showing that the universe operates by comprehensible laws. This began a new era in science where the cosmos was no longer unknowable. It could be predicted and understood. Another milestone Tyson discusses is the role of spectroscopy, spectral analysis or spectroscopy, which means the use of prism to analyze light. When light from the sun was passed through a prism, it showed a spectrum with dark lines. These spectral lines turned out to match those from the chemical elements on Earth: hydrogen, oxygen, carbon, iron. These elements present in both Earth and Sun. So that confirmed the idea that the sun is not made up of something special or heavenly material. It is not made up of some heavenly material. But the sun is also made of the same elements that we find in Earth. Helium, for example, he is taking up the example of helium. It was discovered in the sun spectrum before it was discovered on Earth. That is a powerful moment in the history of science, where helium was first discovered in sun, after which it was named as helium. It is connected to Helios. Okay, but it was actually present on Earth. So this led to a powerful moment in the history of science. Tyson goes further and explores how these laws and spectral signatures apply across galaxies and through time. Distant stars and galaxies, even billions of years old, show the same chemical signatures. The fine structure constant, which helps to define atomic fingerprints, has not changed over time. Tyson also tells the story of nebulum, which is a mysterious spectral line seen in space but not on Earth. It is a mysterious line. So, scientists eventually discovered it wasn't a new element, it was oxygen. Actually, it was oxygen behaving differently in extremely rare field conditions. So, nebulum, which was considered as a mysterious special line on the sky, which is not at all present on the Earth, has turned out to be a kind of an action of oxygen which was behaving differently at extremely rare field conditions, which revealing that Earth based physics still explained it. So, when we come to the major points discussed in this essay, first of all, physical laws are universal. It is uniting Earth and the cosmos. Then, spectroscopy, it has played a crucial role or central role in understanding how the physical laws are universal. We are saying that physical laws are universal, the laws are same in the Earth as well as any part of the cosmos. And they are also saying that spectroscopy has a central role in understanding this, how the physical laws are universal and how these physical laws are working. Then they are saying that the discovery of helium in the sun reinforces this universality. So first of all, we postulated or we have given an assumption, and that assumption or the theory is being explained, and they are giving an example of helium which is discovered in sun, which is reinforcing this universal nature of physical laws. Then they are saying that science combines different laws, thermodynamics, gravity, etc., to model complex phenomena. So conservation laws like energy conservation, like mass, energy, momentum, apply universally. So conservation laws like mass conservation, energy conservation, momentum conservation, it is retained. It cannot be created, it cannot be destroyed. It is as the same. So these laws are applied universally. Our understanding evolves, but the laws remain reliable across time and space. So these are the major points discussed over the chapter. This essay is actually deeply grounded in some of the major scientific concepts, and let's look into that. First of all, it's Newton's law of gravitation, which is explaining the motion of Earth and motion in Earth and in space. The example of apple falling into Earth, and also Earth or the Moon is orbiting. Then Einstein's theory of relativity, that is enhancing this massive objects and extreme conditions. Then spectroscopy, it gives us an atomic level information from light. And then comes conservation laws, which shows the universe operates consistently. It is consistent. Then the fine structure constant, which is like a universal fingerprint of the atoms. Then comes thermodynamics actually. So Tyson also references fluid mechanics, thermodynamics, like in the modeling of comet impacts. He's talking about the modeling of comet impacts. So he was talking about the fluid mechanics, how a liquid is, what is a fluid, how a fluid acts, and what is the Bernoulli's theorem and all. Then about the thermodynamics, there are different laws of thermodynamics, how heat is retained and all. Here Tyson provides strong evidence that about this Earth and the Sun universality. Tyson provides strong evidence that the same atomic laws apply on the Sun and the Earth. Spectral analysis, in this answer you have to write spectral analysis. Spectral analysis proved that both Earth and the Sun share the same elements, and physics work the physics works identically in both places. There is no difference. The discovery of helium in the Sun before Earth adds weight to this point. In short, our understanding of atoms, molecule, and light transcend our planet. So, when there is a question asking how the writer is showing the universality of physical laws in Earth and Sun, you have to write all these points, like why Tyson writes this, and what is the law, what is the nature of the universality of laws, what are the atomic laws he is mentioning, and what about the spectral analysis, and what is the example. So where is the example? It is about helium, isn't it? And in short, our understanding of atoms, molecule, and light transcends our planet. That's what he is mentioning here. Then next, two major physical constants. Actually, it is a relevant question that can be asked from this chapter. So Tyson highlights majorly two fundamental constants. First thing is gravitational constant, and the second thing is speed of light. So gravitational constant is denoted as big G. Okay, so it defines the strength of gravity. The strength of gravity, it has remained unchanged throughout the history, or else stars and planets wouldn't behave the way they do. Okay, so gravitational constant is unchanged and it is a constant. That's why we are calling it as gravitational constant. Then we have speed of light. So a cosmic speed limit, that's what speed of light means. It is a cosmic speed limit, just like we drive cars and all, right? So similarly, there is a speed of light. No object can travel faster than that. So speed of light is the maximum speed in which one can move. So no object can travel faster than that. So this is not just a theory. It's been confirmed by countless experiments, and it is central to modern physics. So these two constants, gravitational constant as well as the speed of light, are two major constant, or these two things are central to the modern physics, or significant for the modern physics. Now we have spacecrafts, about the spacecraft. So Tyson beautifully illustrates how we try to communicate with alien civilization using science. So what we were doing to communicate with alien civilization. So the Pioneer 10 and 11 spacecraft carried engraved plaques showing Earth's location and basic atomic structures. So there were two spacecrafts, which is known as Pioneer 1 and Pioneer 10 and Pioneer 11. And these spacecrafts contained Earth's information in basic atomic structures, how Earth is surviving, or how Earth is over there. And the Voyager 1 and 2 carried the golden records with music, greetings, and scientific symbols. Science was chosen because it's universal. So why we are choosing science as a language to communicate with the aliens? Because it's universal, just like we already told in the chapter. It's the language any intelligent species might understand. It's a language which anyone can understand. So Tyson humorously mentions a cartoon where aliens replied, "Send more Chuck Berry." So he is humorously mentioning that. Okay, so science is a language. Science or mathematics especially is an alternative language itself, which can be communicated everywhere because it's constant all over the world. It's constant all over the cosmos. Tyson's charm lies in how he balances science with humor. He recounts a moment when a waiter insisted whipped cream had sunk in his hot cocoa. So Tyson explained with physics that whipped cream floats due to density. Density, that is a matter. Okay, a light-hearted way to reinforce that physical laws are always at work. Many people are asking why we are studying physics, or why we are studying maths, or why we are studying all these kinds of science and theories, ideologies, etc. But it comes handy, it's working. We are applying those concepts even without knowing they are the scientific concepts behind these things. Okay, and Tyson explained with physics that whipped cream floats due to density. It is a light-hearted way to reinforce that physical laws are always at work. His joke T-shirt, "Obey Gravity," and the Chuck Berry cartoon add a human touch to the deeply scientific essay. Actually, he is writing a scientific essay, but while we are reading the scientific essay, we can find these kinds of writing style, which is inculcating or which is incorporating more humor. Okay, so it adds to a deep sense or a human touch through the essay. So, when we are dealing with the final thoughts, Tyson concludes by emphasizing that science provides a consistent framework, unlike human beliefs, which can change with politics, culture, or emotions. So, human beings and human beliefs are subjective. It can change over time. It can change over politics. It can change over culture. It can change over emotions. But Tyson concludes that science provides a consistent framework because it's objective. Human emotions are, or human beliefs are, subjective, but science and its laws are objective. And he notes that the laws of physics do not care about your opinions or beliefs, they just are. In a world where human nature can be unpredictable, the constancy of nature's laws is both humbling and reassuring. So he's saying that we are living in a world where human beings' nature cannot be predicted. Okay, nowadays we are seeing so many newses which is showing that the human nature is constantly changing. Actually, we cannot say that this person is good or this person is bad. We cannot even predict who is gonna kill whom. Okay, so in these kinds of things, in these periods of time, they are saying that nature's laws are both humbling and reassuring when compared to human beings. Now we have a few questions here to reflect on and to discuss. So first of all, why is it important that the laws of physics are universal? So why it is important? Why should we study that the laws of physics are universal? Or what is the necessity to say these things in an essay? Which means they are creating or they are drawing a parallel between the human beliefs which are inconsistent, but the laws which are universal. Then how can science help us communicate with other civilization? It's already answered, because science and its laws are universal all over the cosmos. In what ways does this essay challenge our philosophical views about humanity's place in the universe? These questions can lead to great discussions about science, philosophy, and our future in the cosmos. Okay, so this chapter is a rich chapter which details upon the universal nature of scientific discoveries and scientific laws over cosmos. At the same time, it intends to create an awareness of the constantly changing human nature or behavior, and they are creating a parallel between the inconsistent human behavior or human nature and the consistent and universal physical laws. So that's all for today. Thank you.